Day 2, Problem 1. Part A, identify the slope and y-intercept for the graph of y equals negative 3/5 x plus 1. So in Part A, we want to find the slope and y-intercept of this equation. And because this equation is in the form that it is in, where the letter y is alone, and then the equals, then the x term, and then the constant, this is called slope-intercept form. And it has that name because the numbers that we see in the equation are the slope and the y-intercept. And so without any math work at all, we can identify the slope, which is the number multiplied to the variable x, as negative 3/5. And we can identify the y-intercept, which is the number on the end called the constant term, as positive 1. The y-intercept is 1. And so Part A is finished. Now Part B, graph the equation. We can draw a line that is the graph of this linear equation by using these two pieces of information about the line. Start with the y-intercept. The y-intercept is positive 1, and so on the y-axis at positive 1 is a dot. Now we can use the slope, negative 3/5, to find another dot on the diagonal line. Now slope is also called rate of change, how the y values are changing as the x values change. Now when this is a fraction, one way to use the slope would be to say when x increases by 1 unit, the y value will decrease by 3/5 of a unit. But 3/5 of a unit is some sort of fractional guess between here and here, and that's kind of difficult to do accurately. So I'm going to approach this a little bit differently for the rate of change. A rate of change is also a ratio of numbers. You can think of it as a fraction, negative 3/5, and take a guess at a fraction, but this is also a ratio of numbers, negative 3 compared to 5. And let's use that concept to do the rate of change. In this case, the negative 3 would mean that the y value is decreasing by 3, and the positive 5 means the x value is increasing by 5. And so from the dot we've already found, let's decrease the y value by 3, 1, 2, 3, and increase the x value by 5, 1, 2, 3, 4, 5. Here is another dot on the diagonal line. Now Day 2, Problem 2. The table shows a person's weight during a dieting program. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and initial value. Let's start with rate of change. From one row to another row on the table, we can determine by how much y is changing and by how much x is changing, and then write a ratio of those two numbers, just like how in the previous problem this was a ratio of two numbers. It doesn't matter which rows we look at, but we could look at the first row and the second row. From 1 to 3 is an increase of 2 months. And in the 2 months, from 202 to 200 is a decrease of 2 pounds. This person is losing 2 pounds every 2 months. And that is rate of change. Again, remember to put the change in the y values on the top of our ratio and the change in the x values on the bottom of the ratio. So negative 2 pounds compares to 2 months. Now this is reducible. Negative 2 divided by 2, it's much simpler to say negative 1 pound in 1 month, or negative 1 pounds per month. Now the initial value. The initial value is what is the person's weight to begin with before they start the dieting program. In terms of symbols, that's asking what is the value of y when the value of x is 0. Now in the table, we don't know a row that has x is 0. Our first row given to us is x is 1, but we could work backwards just that 1 month back to get x is 0. If we go 1 month back from 202 pounds, using the rate of change that we figured out, we can determine what was that person's weight 1 month prior. And so for the initial value, start with our first known piece of information. At 1 month, the weight is 202, and work backwards 1 month prior. That person was 1 pound heavier a month ago. Their initial weight was 203 pounds.